So this is for Unit 1 transformations, and the topic is verifying even or odd functions algebraically. So the first justification we're going to look at is for even functions. So let's do a sketch of a quadratic, the parent function, y equals x squared. And we're going to draw in, let's have it a little bit above the x-axis. So we'll call this x sub 1, this will be x sub 2, and then this will be negative x sub 1 and then negative x sub 2. I do not want to give these values because it doesn't have to be 1 and negative 1 or 2 and negative 2. It can be any value depending on what stretches or compressions might be occurring or shifts. So if we look at this, the outputs for x sub 1 and negative x sub 1 are going to be the same. And we will also say that the output values for x sub 2 and negative x sub 2 will also be the same. This creates that reflective symmetry, which is how we can determine whether a function is even or not. So if we take a look at this, we already know that right here, that's going to be f of x sub 1. That's the output for x sub 1. But what if we use the input negative x sub 1? So if I do f of negative x sub 1, does that give me the same output value as x sub 1? The answer is yes. All right, so f of negative x sub 1 is equal to f of x sub 1. This relationship right here, that tells me that a function will have reflective symmetry, that for any negated x value, I will get the same output as the opposite x value. So this means we have reflective symmetry. Now for odd functions, if odd, then f of negative x is equal to negative f of x. What does this mean? So let's take a linear function. We're going to do the same setup that we did for the quadratic. We'll call this x sub 1. This will be x sub 2. Whoops. This will be negative x sub 1. This will be negative x sub 2. So now we're looking at the relationship between these output values with their input values. So this right here, we can call this f of x sub 1. We want to know, how do these two outputs relate, all right? If I plug in negative x sub 1, what is the output going to do? Well, for this output, if I plug in negative x sub 1, it's going to be this same value. They're going to have the same distance from the x-axis, which means this is going to be negative f of x sub 1, which is equal to f of negative x sub 1. So if we were to plug in this input value, we are going to get the same output as when we plug in x sub 1, but it's going to be negated. It's going to be the opposite. So that's where this comes from. If we plug in f of negative x sub 1, we're going to get negative f of x sub 1. The output is going to be rotated 180 degrees, which means we have rotational symmetry. This justification, it kind of circles itself, no pun intended, but I think it's going to be easier using examples rather than just looking at these x sub 1s and negative x sub 1s. So let's take a look. So if you're asked to confirm algebraically if f of x is odd, even, or neither, your first step should be to insert negative x. If you look at both of these, we insert negative x, and we want to see what the outcome will be. Same thing if it's potentially odd, we insert negative x, and we want to see what the outcome will be. So this will be your first step when we confirm algebraically. So we'll have 4 times negative x cubed plus 8 times negative x. And then from here, simplify. The goal is to get back to this. We want to see if we can manipulate this and get back to the original function in some way, shape, or form, 4x cubed plus 8x. So if I look at this, I have negative x raised to the power of 3, so we have 3 negatives. 2 of those cancel out, so now the entire term is negative 4x cubed. Here we only have one negative, so we're going to have minus 8x. So I'm kind of there. I see f of x, but we have these negatives as well. So my next goal, or my next step, is going to be to factor out that negative. So I end up with positive 4x cubed plus 8x. If we look at this, I have f of x here. Right? So we essentially, after the manipulation, we have that f of negative x is equal to negative f of x. And this is the definition of an odd function. All right? So using that negative x, I was able to come back to this, which means this function has rotational symmetry. Therefore, f of x is odd. So that's how we confirm algebraically. All right, let's take a look at this one. Again, we're going to substitute negative x in. So I get negative x, and we're going to square that, plus 3 times negative x. Now, negative x squared, we have two negatives, so that's going to be a positive term. And then we have minus 3x. Now, already I can see that one term stayed the same, and the other one was negated. This poses a problem already for it either being odd or even. Now I can try and play the game I did in the last problem and factor out a negative, but I end up with negative x squared plus 3x. This is not f of x. This does not equal f of x. So we are nowhere near justifying that it's odd or even. Therefore, this one is neither. So it doesn't take a lot. Like, if you plugged in negative x and you simplified and then you tried to factor out a negative, but you're still not back to the original function, you're done. All right, that's all you can try. Beyond that, it's just going to be neither. All right, this last one. So we'll substitute negative x. So we'll have negative x raised to the 5th plus 7 negative x cubed. And then we'll have negative x in the denominator. From here, we have negative x to the 5th minus 7x cubed divided by negative x. Okay, all of them have the same sign, which is what we see in the original. They're all positive. But in mine, they're all negative, so I'm going to go ahead and factor out the negative. Now, a huge misconception. This is what people will sometimes try to do. Remember, this is a rational. A rational function is literally a polynomial over a polynomial. We have two polynomial functions that create one rational function, okay? So in the top, we're going to have to factor out a negative, but we'll also have to factor out a negative from the bottom. So we have this, and then we have this. And then because we have a negative in the top and the bottom, those are going to cancel out. So now we're just left with f of negative x is equal to x to the 5th plus 7x cubed divided by x, which is equal to f of x. So algebraically, we showed that f of negative x is equal to f of x. And if I look back up here, that is the definition of an even function. So therefore, f of x is even. Now, we expect you to show your work algebraically. Obviously, you don't have to show as many steps as I did, but you do need to justify your work. Well, not justify. Well, yes. This is the justification. These are the algebraic steps. And in order to get full credit for a problem, you do have to show both of those because they support one another. All right, hope this helps. Thank you.